why don't we just start with some questions from the audience, and then we'll see whether I have some questions for each of the panelists, and we'll see if we run out of questions from the audience. Who wants to start? Mike, of course. Are you going to pick on everybody, Mike, or?
He's going to start at the end.
No, I only want to pick on Omar. So I thought your 3-tier slide was the most misleading thing I've seen in several weeks.
Excellent.
Because in fact, HBase, Pig, and Hive are all on top of Hadoop or MR, and you sort of show them. You sort of smeared the fact that MR is in fact underneath essentially all of those possibilities. You also put up Hadapt, which is not on HDFS at all. And so I think you're really smearing reality here, and I'd be interested in why you put up a super marketing slide which is technically highly inaccurate.
I drastically oversimplified to make it look sexy. So I did oversimplify, and that was on purpose. So HBase runs natively on HDFS. There's no MapReduce in the middle. That's pretty accurate. Today, Hive and Pig do compile to MapReduce. I don't think that is the inevitable end of Hive and Pig. I think if you look at the community and what they're discussing, sometimes that makes sense. Sometimes it doesn't. And I think one of the questions is what can Hive learn from the database community? And one of those is don't compile SQL into MapReduce, or compile it into more optimized engines. Hadapt, I was unaware. I thought that Hadapt actually did store data files in HDFS. So if I was mistaken, then.
So since I have a mic, I'm going to follow up just with one quick question to Omar. One of the, I understand and I sort of buy into your picture of HDFS at the bottom. And there are some systems out there like Teradata and other ones like Hadapt that, I guess, with the exception of Mike's point, that talk about putting relational capabilities on top of HDFS. We heard a talk yesterday about this data with different temperatures. But HDFS has some real limitations in terms of understanding where the data where a block actually is. And that's one of the beauties, because it gets moved around to take care of failures. And one of the things that relational database systems, parallel relational database systems really like is to avoid shuffling data by co-locating rows of different tables that might join together. And one of the challenges I see in your picture is getting around those limitations of HDFS. And maybe Daruba can answer that question.
Sure, yeah. I think
Omar can answer that question.
So I think co-location of data blocks or co-location of data from different tables, that has come up many times in the past. And I think that works well when you know what your queries are up front. Many times we are joining tables that maybe only once in this entire lifetime, or very, very few times. So what we do is, by design, HDFS has a pluggable block placement policy. So we use some of it now to do, say, intelligent block placement for HBase. But for MapReduce, we haven't done much because some of our queries are a big percentage of our queries are very ad hoc. Because like I said, our Hive and HBase or MapReduce platform is used more as the value add is a lot of value add is because it's an experimental platform. It's where people search for information, right? So we can't kind of co-locate stuff up front because a big percent of our queries are we don't know which tables will be joined together.
Especially with 50,000 tables, so we could talk about that.
Right. So yeah, so HDFS actually does know exactly where every block is. That's how it assigns mappers to run ideally on local blocks.
But if you take a column store and put
so
the columns as different HDFS files.
Don't do that.
Yes. Okay. That's
don't do that. Well, so I mean, don't do that unless it's more expensive to move them over the network and rewrite them, right? So it's kind of if you know enough about your data to optimize where it's placed, use an engine that's smart about placing the data. Until such a time, just kind of be dumb and brute force about it.
Any other panelists want to add something to that, or next question? Oh, Mike. You can't have all the questions. Pat, and then Mike.
Why are you guys being so short-sighted? I mean, intra data center clusters, you're getting more bandwidth. Just provision the network so that all of this ancient issue just stops being an issue.
Well, I sort of assumed that everybody was building high-speed interconnects to connect all of their clusters together. Well, you know, if you got to pick up multiple petabytes of data and put it down for every query, that's a problem. I think this goes back to my point about late binding, right? When it makes sense to cost optimize something, do it. The question I think that is coming up is, do we have the infrastructure in place to do that if you look a little forward? I don't know the answer to that question, but it would be the next one that I would ask.
I think, Drew, how big are the heavy nodes?
Yeah, I think so. My take on that is that, yeah, networks are increasing again, 10 gig, 40 gig, but I think size of our data is increasing more, and the queries are increasing more. So we are always bottlenecked on the top of the rack, although we have a lot of things that we have put in to optimize that. So that's why Hadoop is still popular in the sense it does this data locality. But if network becomes free or stuff like that, then maybe it's not as useful. But as of now, as of today, we still have that problem of network locality. You don't see that on your clusters?
It's getting there.
Okay.
My prediction is that we will see top of rack go away. You will either see some kind of computing platform in between the network, and you're going to go to an array, something with some logic, right? We're going to keep pushing the logic down into the hardware. Yep.
I've been around for arguments about placement of the cylinder on the disk.
Me too. Yeah. But it's nice to know that you could assign it.
So I have a question. So this is about Omer. Now you basically have seen that a lot of commercial proprietary entities are implementing on top of this open source stack. Is the open source community facilitating that enough, rapidly enough, by coming up with new features, accepting the feature request from them? And because I've seen a few examples where the open source community is, for the fear of complexity, did not want to implement some of the features that were needed by the commercial providers.
Yeah, this is where things get really interesting. So, I mean, the community is great in the sense that you get a lot of open collaboration for free, right? You can just take from the community. You can also join the community, but you are subject to the sort of the consensus direction of the community. I think where we've seen the most efficient interaction between community and commercial providers is when commercial providers get involved, and sometimes that works well, sometimes it's more difficult. But there's a lot of people pulling on what they want this open source stack to do. It doesn't always end up optimal. I think Doug Cutting likes to say that the goal of the Apache Software Foundation explicitly is not to produce good software. It's to create communities and rely on the principle that good communities as an emergent property create good software. And so you've seen some commercial vendors end up as a buffer. So Cloudera is an example. We almost described ourselves as a buffer between the needs and desires of the commercial world that's not interested in getting their hands dirty in the community code, and then helping them translate that and amortize it and be able to figure out how can we advance the platform forward to be more compatible with what commercial providers need. But it is, I mean, it's a slowly evolving and it's a very challenging interface.
I have a question for Dhruba, but I'd also like to hear other people's comments as well afterwards. You mentioned that your social graph is stored in a relational database in MySQL. And I was wondering how you do graph analytics on top of that. If you're using Pregel type stuff or MapReduce or plain old SQL or something else.
Okay. Yeah, that's a good point. So I think what I try to convey there is that we have a graph database, but it's stored on MySQL, and the queries are not analytics queries. So that's why we have 4 different types. The analytics queries always happen on Hive. This is a graph database that is used for online data serving. When you're querying your Facebook graph, you are trying to find out all your friends, all your posts from your friends, you are sending messages, chat, or stuff. You're interacting with your friends. That's why that database is an online database. It's not for analytics. So it's point lookups and queries, which is very important for us.
But then you copy that and use Hive to
Correct.
do the
So
graph.
we do daily scraping of those data into Hive, and then that's where we do a lot of analytics of the same data, it's copied into Hive and then do analytics.
So why not use, I mean, you have the graph, you kind of can look at the graph in MySQL. Why put that into HDFS as flat files with Hive instead of a graph database? Because you could, in theory, you could already partition the graph more intelligently.
So yeah, I think, so this is a generic question, I think. Why not use some other database? And I'd like to address that. I think it is not because Hive and HDFS are the greatest databases that we use it. I think we use it because we want the data in an open format so that we are not locked into a vendor. I think that's very important for us. So if there is any alternative DBMS solution which is open and which can scale to say 100 petabytes, we will very much like to use it. So that's my point, is that it is not because we use Hive because it's really fast and performant. I think it's very critical for us to get an open data format, like many of us mentioned, because we want to access data from many different angles, not just from the database APIs. And it's the data which is the API, not the application which is the API.
All right, so SQL kind of gets you there in a generic sense. But I can tell you what we've done at Zynga for that problem. We looked at graph databases. We had a massive amount of data we wanted to aggregate, and we tried to calculate what we call the active social network. So instead of like who all my Facebook friends are, who are my friends on Facebook who I'm actively communicating with, messages or playing games with. So that turns out to have a really high correlation with retention and engagement. So to solve that, we started looking at some of these graph databases like Neo4j and some of these others, but they couldn't meet our scale. So, SQL obviously is an optimal place to be doing graph analysis, but we took a shot. We threw it in Vertica. Turns out it handled the scale because it had the MPP issue, and we're doing it within an hour and a half. We take our entire universe, and we're able to calculate this active social network and other metrics very quickly within the database using SQL. So, there's always, so in our use case, that worked.
John?
Hi, John Hacks with Oracle. 2 points. One, in theory, you can't, to say in theory I can partition a graph database, the problem with graph databases is you can't partition them because you don't know your knowledge. So trying to calculate nearest neighbor in a graph database, you don't know the relationship, and it's that unknown relationship that most often in a graph system you're trying to find. And so that's your problem.
It was a bit of a leading question.
Yeah.
Right.
And my other point, I'm going to just bring up one other point. When I hear somebody say, oh, just move data across the network, I have to laugh. Everything you hear at XLDB and a consistent theme is don't move the data. And that sort of is what defines big data. I can't move it. So storage is getting cheaper and cheaper and cheaper. I can tell you network is not getting cheaper and cheaper and cheaper.
Actually,
so
I think network is getting cheaper and cheaper and cheaper. It's like I just bought a pair of 64-port 10G switches. It was under 100 grand. It's getting cheaper, a lot cheaper. Now, you can make the point that if I have a 50 petabyte problem, there aren't going to be enough of those switches. I think we have a boundary issue there, but it is getting cheaper. I don't think we should be moving all of this data around, but I think also to other points that Omar made in particular about Michael's work is, look, we're specializing. And at the same time, we're trying to constrain the amount of movement that we have, right? And we just need to get better at identifying when to move it. When we choose to do that, we need to make sure it's simple and easy and fast. But we just need to keep pushing down the logic until you have to make that decision. I think we just, as an industry, I don't think we know enough about the boundaries of that problem, right? So.
Yeah, I wanted to continue on the same theme. Mike in his talk said, he wanted to integrate all this data together, but he didn't want to use federation technology. He wanted the systems to talk to each other as peers, if I'm paraphrasing. But the companies building these systems don't really have an incentive to do that. The way they tend to work is if you want to use Vertica or another data management system, you have to copy it into Vertica. And so it's an idealistic view that I share, but how do we get there from here? How do we incentivize these systems to talk to each other rather than just requiring copying all the time? Or plan B seems to throw it all, is to throw it all into HDFS and experience awful performance. So.
I can tell you what we're going to do at the outset. We have a bunch of these. We're going to move the structured data onto a single platform. We have other platforms to deal with. We are absolutely going to use HDFS. That will be the first target. But I'll tell you, if a vendor comes to me, and I had one last week, gosh, great looking technology, want to go test it out, but the bar to move data in and out of the platform was so high, it was like, well, you don't have any interfaces except for a bunch of straws. I have, not only do I have fire hoses, but what I really have is a dam back there, and I just want to let the dam go.
I think that's the answer. Vendors do what their customers ask, or they cease to become vendors.
Yeah.
Right. And so if the customers say systems got to talk, then eventually that will happen.
If you're going to come into our shop, if you're going to require me to run loaders and write a bunch of code, I can't buy your gear. It's that simple.
Omar, then how do you reconcile Cloudera's push on Scoop? Because Scoop is like the worst straw possible in terms
Scoop
of...
2.
Pardon me?
Scoop 2. No, I'm serious. We didn't, we kind of created Scoop to fill a gap. It's not the end all be all. We got a lot of really good feedback. So we wrote with Teradata and Netezza and with Oracle, we wrote higher performance connectors than like JDBC. And as a result of that, we realized we couldn't actually do things like TPT, which is the fastest way to move data in and out of Teradata. And so it needs a new architecture. And so Scoop 2 is kind of the attempt to create a system that's better at handling those kinds of problems. But it's evolving. Scoop was good for what it solved.
And Mike, do you agree that Scoop 2 is the answer?
There will be a version after Scoop 2.
Yes, there will. I hope so, only if it's useful.
Well, we've got one running. We'll have to talk about that after.
Send us the code.
No.
Is there a question? Was there a question there?
Mike still had a question which he hasn't asked, I know.
So,
No, I mean, you're next, Mike, after this.
okay, sorry. So I have two questions, because I know Mike's going to have three more. So question number one, I don't think I actually heard the answer to this, and this is actually Mike's original question, which is, Hive is still really slow, and you told us, well, we use it because it's flexible. Is it possible that we could build a flexible and fast system, or is it just mutually exclusive?
Yeah,
And
no,
then-
I think we can build.
Well, Hive was, how many years ago did we create? Hive started?
Maybe we started it in 2009.
So
or
it's
2010,
3 years
2009.
old. I think, if you compare,
So-
for reference, Vertica of today to Vertica of 3 years, it's a hell of a lot faster. I think there's a lot of improvements, but.
Yeah, there's nothing inherently slow. It's just that a lot of pieces of the implementation have to be rewritten. Small pieces here and there rewritten, so you can't just rewrite one portion to make it fast. It's not one portion which is slow. So, and also you'd see the number of contributors to most of these open source platforms have increased a lot. For example, I focus mostly on HDFS, and there are probably 250 or 300 people who have contributed code. Never managed a software project which has this many people changing stuff. So it's kind of a different world. For Hive, there has been a lot of focus on to make it faster, because there is another angle to this, is that if we can make queries fast, and I think then there's more innovation, because in our experimental platform, people can run more queries on the same time. So that's very much in our focus.
So great. So the second question is, we've been focusing on performance, scale, and more performance and scale. But what I'm hearing outside in the world is, I don't really know how to run Hadoop. I don't know how to manage it. I don't know where to get the guys to go and run it and use it.
Yeah, just
And
give me a
there's
call.
one Omar.
I don't want to do marketing stuff. Yeah, just call me, and I think the interesting stuff is kind of in the performance scale at XLDB.
Right, but even then, right? I mean, there's this tension, which is, okay, one size doesn't fit all, and you need a variety of tools and so on and so forth. But as you have more and more tools, it gets harder and harder to put these things together and run them in a sane way.
I think you can compare it like saying how easy is it for you to recruit system administrators for Linux versus Windows, or MySQL versus Oracle. Maybe that might give you some ideas, like how things might progress over time.
It's easier over time.
Yeah, I think it gets easier over time.
Yeah, I will also say that, I think you run into a lot of infrastructures which are just too complicated. We have to learn how to retire stuff, right? And we all have stuff in our legacy systems. I know I'm a bad example. I walked into a 100-year-old company, but we have to learn how to retire things. right? We create too complicated a stack, and then we can't run them. And oh, by the way, when we're running them, we can't redirect skill sets to other things. Right? So it's not just a skill finding problem, we're just creating too much complexity. Right? And so I think we have to have a balance. There are specialized things you have to do, but we also have to say, okay, well, how do I generalize this? And so one of the comments I was going to have about the early part of the question is, okay, well, Hive is slow relative to what? Right? And is it really relatively slow to the cost equation of why it's there to begin with? Right? And I don't know that that's necessarily true. Right? So for you guys, it's about flexibility. Also, you have a skill set that's available to you that we don't. But that's not really the point. It's like, okay, what does it really cost me to do that? And when do I promote some function into a more scalable and more performant thing? And I think that's the question we have to start asking ourselves and answering appropriately.
That kind of ties into our benchmarking thing, right? So I think traditionally we have benchmark latencies. But what I'm suggesting inside Facebook is that we are kind of bottlenecked on disk capacity. So there was an experiment that we did earlier to calculate a benchmark, which is like the value per byte. How much value of this, that's what we need to optimize our database for, the value per byte, not per like latency or access, because we want to store everything in there.
Is that something that you'll also, I'm very interested in.
So we have some experiments that we have calculated internally. But this is the metric that I think is interesting, at least to optimize on a certain angle for us.
And we talk about this somewhat when we explain to people why you would care to use Hadoop is we kind of talk about as return on byte, right? A raw byte off the wire, you have no idea if you're going to get any value from it. Either throw it away or keep it in the cheapest place possible that you can get at it. But if it's the record of a transaction and you're going to analyze it later and you're going to be able to do analysis on trending and you're going to be able to file your taxes off of it, it's very valuable bytes. And it should go in a system that can meet the performance needs of that value.
So what I kind of heard you guys say is, well, the Hadoop MapReduce layer was a big left turn off into the great beyond, and so we're going to throw that away and get higher level interfaces to run directly on HDFS. That's what I heard you say. And
yes and no. I think there's some stuff that you'd keep running against MapReduce, and there's things it doesn't do well. But if you have the data there and you can create different engines, so you put those directly on HDFS.
Okay, so
HBase as an example.
So, but what you're basically advocating is that all of the innards in between Hive and HDFS are going to be made fast with some committee of database developers. And I've never seen any performant, reliable database system written by committee. I mean, I think writing 500,000 lines of code. I mean, writing a database system is not something to do with 500 part-time pickup people, and it just seems like you're fundamentally almost guaranteed to fail. Number two,
Mike, this is another business opportunity for
you. Hold on.
Number two,
challenge accepted.
As near as I can tell, every single parallel database company on the planet either has now or soon will have a Hive to their SQL translator. So, I mean, Vertica is going to support Hive in short order. And it seems to me you're going to get completely co-opted by the commercial vendors who are going to get there way faster with way better products. And why are we having this big Apache discussion on whether they're ever going to get there? Because they're not.
I'll let the Hive PMC member answer.
Yeah, I think it's a question about how you look at software. I think the foundations you are talking about are very old foundations, because I think the foundations are changed. Like previously we used to build houses with a crawl space. Now it's all flooring, right? Permanent flooring. So what happens is that it's only in the last 10 years I've really seen open source software take off. That depends, I mean, you'd probably see Linux and MySQL.
Notwithstanding Postgres.
Oh yeah, that's true. Postgres was another one too. But I also agree that sometimes as open source software, it's difficult to optimize for different things. So although we have, say, 200 engineers doing stuff to Hive and HDFS, it's likely that a lot of them are focusing on scale and not on performance. because of the contributions or because of the background of some of the people. So I think what you are saying probably makes sense, that there are a big chunk of people who still use commercial databases, but I think there will be a big chunk of data in the world which will be in open format. And that might not be Vertica or Oracle, for example.
Yeah, my experience has been, I guess, twofold. One is that while the community is large, the different problems will usually have, I don't want to say subcommittees, but smaller groups. You'll have a team that says, we're going to tackle problem X, and admittedly, fundamental changes to something like Hive is a big problem, but you'll have a small group that says, we're going to bite off this piece, and they'll form sort of a small independent team that publishes everything, so there's full transparency, but they don't fix it as a group of 500. The other one is that Hive, I don't think, is interesting exclusively because it kind of looks and feels like SQL. It looks and feels like SQL because people are used to SQL, and therefore they want something that feels like SQL to access the data. But it's that the data is coming in various formats that are not yet structured and optimized. It's the very first time you touch it, I can either touch it with a loader script written in Perl, or I can touch it with SQL. If I can touch it the first time in raw format with SQL, that's a lot more interesting. And the second time, it might be coming out of Vertica. But the very first time I look at it, and when you have 100 petabytes, you're looking at new data a lot for the very first time. Having SQL access to new and open formats of data is where Hive becomes interesting.
I have a related question. It's along the lines of open source, and what I've seen happen often is there's tremendous innovation at first with open source. And then a project gets to a certain size, and what companies tend to do is they take it in-house, they branch it, and they continue the innovation. But that innovation never comes back to the open source world. So you guys are the experts, and I'm wondering, is there a solution for this problem, and what is that solution?
It's really hard. I mean, we have a policy at Cloudera about how to open source software. It's a 15-step process. One of those steps is publish the software. Pretty much everything else is how do you build and foster community. And you have to focus on it. I think if you're taking open source software and you're not going to track to the open source or interact with the open source, you run that risk unless you make the investment to do so.
I also think to that point that in every large company that I've been in where we've been through that process, it takes a couple of years, right? It is, and that's just to set up the process, right? Running the gauntlet with the lawyers, and we all hope that our lawyers are better than everybody else's lawyers. You got to have them. It takes a couple of years just to set up the process. And so this is a complicated thing, right? And most organizations, particularly older ones, culturally, don't think that way, right? What was my response? Give us the code. No. I already got told no. So it's a complicated problem. I think this kind of goes back to what Mike was talking about, which is, well, hey, wait a minute. All right, we've got some infrastructure components. Are we really competing, right? So one of the other points that you made earlier, Omar, are we a good community? I don't know that we are. What would be the definition of that? And so if things end up moving into the commercial side and that's the right place for the market to take it, great, right? I would kind of question whether or not I want a couple of SQL translation stacks, or if I want multiple languages, which essentially is what they are, they may have a foundation, moving into separate products. I'm not sure how I feel about the complexity of that.
I heard from one of the companies we work with that did decide to start for the first time open sourcing software in excruciating detail the number of times that an engineer had to sit down with 3 separate lawyers and explain word by word, like this is an if statement, right? This is a while loop. It is not proprietary because, right? And over again. But the second contribution was a little easier, and the third contribution was a little easier.
So, David, we are slowly starting to run out of time. Do you want me to keep asking questions? There are still questions. It's clear. Okay. So you're first.
So continuing actually in that open source discussion, why don't companies, what can open source community do in order to keep companies from branching off their codes, et cetera? I think Hadoop has done a very good job over the last years because the APIs in the open source keep on changing. So you have to contribute back so that it gets tested at that scale. But that's not what I'm going to talk about, ask about. It's basically that, lately as Hadoop has sort of matured, has been deployed on large sets of clusters, et cetera, there is always a permanent tension that I can see going on with whether scalability related features and performance, right? These are mutually, I won't say mutually exclusive, but a large portion of that are actually mutually incompatible, right? So the second thing is that open source is very good at incremental changes, major feature development, et cetera. We have seen lately that a lot of major feature development that has to happen in Hadoop is sort of, been on the backlog for a long time and takes a long time to stabilize, et cetera. So what are your thoughts in terms of, in Facebook as well, I sort of have this hunch that you don't run all the features or all the fixes that have been, so-called fixes that have been committed to the open source. You have your own version of that running. What makes you not have your own distribution open to the public, for example?
Yeah, I can address a little bit of that. So yeah, I think open source has this thing is that there is constant tension between different communities. Somebody wants to do performance, somebody wants to do scalability. So what we have done is that I think it's a culture of the company. So for us, for infrastructure, for our company, the focus is to keep infrastructure open. So when we write new software, the question is why have you not open sourced it versus why do you need to open source it? The question that people ask us is very different. People ask us questions about why is this software not open sourced? So the culture is built into the company. But that, to translate to the Hadoop world, what happens is that many times our code base is slightly forked from the Hadoop trunk. But when we develop new features, like for example, we have encoding in HDFS, Reed-Solomon encoding, so we contributed it back to the Apache open source community. So there are big features that we have contributed back to the open source community, but you are right in the sense that it's very difficult for us to run open source Hadoop trunk because we need to develop stuff faster sometimes or sometimes slower based on, in spite of what the community is doing.
Yeah, I don't think people don't run trunk. I think one thing the community can learn from this is if there is a large feature, don't wait for someone to tackle it. Nominate a small group to go and tackle it. And this happened with security, it happened with high availability, and you just kind of pick a team and say, only a small team can solve this problem, and we're going to respect the decisions of that team. You have our blessing, go do it. And I think that's something the community is not used to today.
One last question.
One last quick question.
Yeah, I heard from a number of you guys the importance of the simplicity, and I'd like to see your reaction if you contrast that to automation, aggressive automation. So I heard like some companies have, as a solution for the redundancy problem across data centers or something, they just have people issue rsync commands. And so, there's this trade-off between manual errors versus a bug and your automation. What do you guys think about that?
I think it's automate and verify, right? It's the question of automation is a no-brainer. Automate everything you can, but realize it's not going to be perfect and instrument it like crazy.
It introduces complexity, but it removes some complexity at a different layer, right? Your support infrastructure and your maintenance is, right? It all depends upon where you go. So for example, my test for simplicity is if I can't explain it to my C-band and get budget allocation, it's probably too complicated. Okay, because it doesn't contribute anything. I have to be able to explain it. Now, partially that is the artwork of, being verbal and being able to tell a story, but it's also about, if you don't do the automation, right, then the glue that you put everything together with is unmaintainable, and then you have complexity that's run amok. If you put automation in place, you incur some maintenance cost, but you simplify your operations problem. So, I would look at automation as simplification, largely. For me, it is.
From what I've seen, it's a lot easier to look for the outliers on a monitoring stream and then deal with those than to actually manually do the process that underlies it, whatever it is.